In this video, we will be going over the answers to Lesson 1 line plots, the independent practice pages 867 and 868. Good day, Springford math students. Question number 1. Make a line plot for each set of data. Find the median, mode, range, and any outliers of the data shown in the line plot. Then describe the data using them. Question number 1. Length of summer camps in days. When you go to summer camp, some programs may be 5 days, some camps might be 2 weeks or 14 days. It all depends on what type of camp you go to, and they offer different lengths of time. We're going to make a line plot of the camps that they surveyed, and the first thing we need to do is have a title. Length of summer camps. Remember, when you make a line plot, you want to make your x's uniform in size and spread out evenly. If you did this correctly, your line plot should look like this. The first data point that they would like us to find is median. To do this, we have to put the data in order from least to greatest. Now we need to find the middle number because we're looking for the median. The median is the middle number of your data set. Middle has an I and median has an I. This helps us remember. I go left, just finding my pen here. I go left, 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 right, 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 left, 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 right, 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 right. I have two numbers in the middle, 7 and 8. My median will be between them. I have to ask myself, what is between 7 and 8? That is 7.5. So the median number of days of camp would be 7.5 days. The next data point that they want us to find is mode. Mode is the data value that occurs the most. We can remember this because most has an O and mode has an O. Sometimes students get confused between mode and maximum when they're looking at a line plot. The mode is the one that happens the most, so it has the most x's. This would be 7 days. It is not 12. 12 is the maximum amount of days that any one camp had. But mode is the one that most camps offered, and so most camps offered 7 days. The next data value they want us to find is range. Range is the maximum minus the minimum. We've already established that 12 is our maximum, 5 is our minimum, and so 12 minus 5 is 7. Our range is 7. Sometimes I see students look and say that 14 is the maximum because it's the highest number on our number line. Or maybe if our number line extended past 5 and was 4 or 3, they might do 14 take away 3. The number line can be as long as the person who made the number line wants it to be. It's the data values that you are subtracting. Our next data value that they want us to find outliers. By looking at this graph, I can tell that there really aren't any outliers. But if I want to determine this mathematically, I'm going to need to find the interquartile range. We're going to abbreviate this with IQR. Just to review, the interquartile range takes a group of data and divides it into 4 equal parts. This would be called quartile 1, quartile 2, and quartile 3. They're the cuts. So when we cut our data into 4 equal parts, it takes 3 cuts to make 4 pieces. Now, the median is the middle, that's our first cut, and that's quartile 2. We're going to cut the lower half of our data in half. Left, 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 right, 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 left, right, center. This would be quartile 1. We're going to find the upper half, which is quartile 3. So we're going to go left, 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 right, 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 middle. This is quartile 3. Now, we have split our data into fourths. 1, 2, can't really see my thing, 2, 3, and 4. So I have my data split into fourths. And now I'm going to find the interquartile range. The interquartile range is the difference between quartile 3 and quartile 1. 10 take away 7 equals 3. Now, to determine an outlier, you multiply the interquartile range by 1.5. 3 times 1.5 is 4.5. Now, we take that and we add it to quartile 3. So we add 4.5, and that gives us 14.5 days. So any value that is 14.5 days or more is an outlier. Our maximum is 12. So in the upper portion of our data, we have no outliers. Let's take a look at our lower portion. We're going to subtract 4.5 from quartile 1. So we have 7, take away 4.5. That's 2.5 days. So any value that is equal to 2.5 days or less than 2.5 days would be an outlier. Our lowest offering for a camp is 5 days, so we have no outliers on the lower portion of our data. In summary, median is 7.5, the mode is 7, range is 7, no outlier. There are a total of 18 summer camps represented. The median means that 1/2 of the summer camps are longer than 7.5 days and 1/2 are less. More camps are 7 days than any other number of days. Question number 2. Students' estimates of room length, and the unit they used is meters. Step 1, we're going to write a title. Next, we're going to plot each point on our line graph. If you did this correctly, it should look like this. The first data landmark that they want us to find is the median. all of the data in order from least to greatest. I still find that it's helpful to list them horizontally. And now we just count to the center. Left, 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 left. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. So this is the middle number. So our median equals 15 meters. I do want to point out here, do you notice that I'm not actually crossing out the values? I'm underlining them. Sometimes I see when students are finding the middle of a number, they're crossing out the number. That just makes the number more difficult to read later on. So if you're going to count by marking like most people do, either mark above or below. Try not to cross off numbers. All right, so we found the median. Now we're going to find the mode. And remember, that's the most often occurring, which is right here, 15 meters. So the mode equals 15 meters. Next is range, which is the maximum, 25, take away the minimum, 10. That gives us a mode of 15 meters. I'm seeing a pattern here. Now, are there any outliers? I suspect that 25 is an outlier, but I'm going to prove that mathematically. So we're going to find the interquartile range. All right, so I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, and then 17 and 17. Okay, so 17 is going to be my quartile 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is 13 and 13. So 13 is going to be quartile 1. And remember, 15 was quartile 2. Our interquartile range is the difference between quartile 3 and quartile 1. 17 take away 13 is 4. So the interquartile range equals 4. Now we're going to multiply that times 1.5. And that's 6. I'm going to add 6 to 17. And that equals 23. I'm going to take 6 away from 13, and that equals 7. So are there any outliers in our data? No outliers. Even though 25 looks like an outlier, it actually isn't an outlier. In summary, the median, oh my gosh. The median is 15, the mode is 15, the range is 15. Now, they actually said that the outlier is 25, and I gotta be honest with you, they are incorrect because it's not. So I'm wondering if they just wanted you to like kind of estimate that. I mean, it is close to being an outlier, but the reality is if you follow the calculation for outliers, it actually isn't an outlier. So I'm guessing that they just wanted you to like make an estimate here. There are 25 room lengths in meters represented. The median means that 1/2 of the rooms are greater than 15 meters and 1/2 are less. More rooms are 15 meters than any other length. Question number 3. The line plot shows the number of songs in playlists. Describe the data. Include measures of center and variability. Now, they're asking us to include measures of center and variability. They've already asked us to find the median, which now they also want us to find the mean. They want us to find the mode. They want us to find the range, which means we also will have to find the maximum and minimum. They want us to find the outliers, which means we'll have to find the interquartile range. All right, so let's get started. We're going to start with the median first. To do this, we're going to record all the data using the graph in order from least to greatest. Now we're going to count to the center. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Center. So the median is 40. Next, we're going to find the mean. In order to find the mean, you need to add up all of the values and then divide by the number of values we have. So you should pause the video and add up all of these numbers. If you did that correctly, you should have 600. Now we're going to divide 600 by the number of data values that we have. You can choose to count the numbers that we've listed here, or you can count the x's up here. Regardless, you should have 15. Now, in your calculator, do 600 divided by 15, and you will get, dun, 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 dun. So the mean is also 40. So the middle number is 40, and the average is 40. Next, we're going to find the range. The range is our maximum value minus our minimum value. So that would be 47 take away 25. And if you do that, you should get 22. So the difference between the person that downloaded the most songs on their playlist and then to the person who downloaded the least songs is 22 songs. All right, next we have mode, which is what do most people, or what did most people download? Remember, you can have no mode, one mode, or more than one mode. In this case, we have 2 modes. The most frequently downloaded amount of songs on a playlist was 40 or 42 songs. Now it's time to find some outliers. I'm going to do a little bit of erasing here. We already found quartile 2. Now we're going to find quartile 1. Left, 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 right, 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 middle, left, 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 right, 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 middle. Okay, so this is quartile 1, quartile 3, and the interquartile range is the difference between the two. So we're going to have interquartile quartile range equals 42, take away 38. So the interquartile range equals 4. To find the outlier, we're going to have to do is the IQR times 1.5. So we're going to have 1.5 times 4, which is 6. I am going to add 6, and I'm going to take away 6. So 42 plus 6 equals 48. So that's actually going to go way up here, 48. So on the upper portion of our data, we have no outliers. Now I'm going to subtract 6, and that's 32, which takes me right here. So anything 32 or less is an outlier, and guess what? We have an outlier, 25. So 25 is an outlier. So the interquartile range equals 4, and we have one outlier, which equals 25. If we put this into a paragraph, it would look something like this. There are 15 playlists represented. The mean is 40, the median is 40, the modes are 40 and 42, so the majority of the data is close to the measures of center. Q1 is 38, Q3 is 42, the IQR is 4, which means half the playlists have between 38 and 42 songs. There is an outlier at 25. Inductive reasoning. The number of runs a softball team scored in their last 5 games is shown in the line plot. How many runs would the team need to score in the next game so that each statement is true? Take a moment to look at the graph. Now, what's happening here is that a team played 5 games, and in one game they scored 6 runs. In 2 games they scored 9 runs. In one game they scored 11 runs, and in one game they scored. They have a game coming up, and we're going to be adding an X to represent that game. And we want the following statements to be true. Now the X doesn't have to be the same for questions 4, 5, and 6. Let's take a look at question 4. After their next game, the range will be 10. All right, well, let's find out what is the range now. Well, we have range equals the maximum, which is 14, minus the minimum, which is 6, and that equals 8. We want the range to be 10. This means we need to increase the range by 2 runs. We can do this by increasing our maximum by 2 and making it 16. So if our maximum is, if there's an X here at our next game, our maximum would be 16 and our minimum would be 6, and that would equal 10. Another way to do this would be to decrease our minimum by 2 and put an X at 4. So if in the next game they score 4 runs, our maximum would be 14 and our new minimum would be 4, and that would be a range of 10. So they could score either 4 or 6 runs in the next game, and that would result in a range of 10. All right, question number 11. Another mode is 11. Right now, our mode is 9. We still want 9 to be a mode, but we want an additional mode, another mode, to be 11. So in the next game, they are going to score, and their score is going to make 11 another mode. Well, this means that it has to be 11. So if we add an X here to represent the next game, we'll have 2 9s and 2 11s. So in the next game, to make that statement true, they need to score 11 runs. Next, question number 6. The median is 9.5. And I need to be honest with you, I actually solved this problem and I read that really quick and I thought that it said mean. So I calculated everything for mean and then I had to go back and redo it because then I realized it was actually median, which actually makes our life a little bit easier. So let's find the middle number currently for our data. We have 6, 9, 9, 11, and 14. And if we go to the middle, we go left, left, right, right, middle. All right, so we have to start thinking here because right now our median equals 9. We want to increase that. So am I going to be putting a number to the left or am I going to be putting a number to the right? Think about that. Am I going to be, all right, so this is tricky because you have to really think, all right? All right, so let me tell you. 6, 9, 9. I want to increase it, so I'm going to have to put it to the right, but I can't put it over here. Where am I going to put it? I'm actually going to put it right here as a 10, 11, and 14. Okay, so I have left, 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 right, 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 middle. And what is between 9 and 10? 9.5. So if in the next game they score a 10, or they get 10 runs, then the median will be 9.5. Question number 7. Find the error. Dwayne is analyzing the data in the line plot. Find his mistake and correct it. The median and the mode are 23 degrees Fahrenheit. The outlier of the data set is 20. Well, right off the bat, all right. Right off the bat, I think it's pretty obvious to see that the outlier is not 20 because there's no data value in 20. So he should have said that the outlier is 29. Now let's check his other claims. Is the median and the mode 23? Well, the mode is definitely 23 because that's the most. So let's see, is 23 also the median? So we have 21, 22, 23, 23, 23, and 29, and hold on one second. And we go left, 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 right, 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 so that is true. So the only thing he said that is not true is that the outlier is not 20, it is 29. Question number 8. Write a survey question that has a numerical answer. Some examples are, how many CDs do you have? Or, how many feet long is your bedroom? Ask your friends and family the question. Record the results and organize the data in a line plot. Use the line plot to make conclusions about your data. For example, describe the data using the measures of center and variability. Now, unfortunately, I can't really go over this with you, but I do encourage you to do this with your family. Question number 9. Persevere with problems. There are several sizes of flying discs in a collection. The range is 8 centimeters. The median is 22 centimeters. The smallest size is 16 centimeters. What is the largest disc in the collection? All right, so we're going to set up a line plot here because we do have some information. We know right off the bat that the smallest size is 16 centimeters. We know that the median is 22. And we're looking for the largest disc, which is the maximum. We're told that the range is 8 centimeters. Well, this is very helpful because I know that the range equals the maximum minus the minimum. And the range is 8. We don't know what the maximum is, but we do know what the minimum is, and that's 16. So now I'm going to add 16 to both sides, and the maximum equals 8 plus 16, which is 24. So the largest disc in the collection is 24 centimeters. This is a hot problem because they were actually trying to get us off target here by giving us too much information. We really did not need to know that the median is 22 centimeters. Question 10, construct an argument. Determine whether the statement is true or false. Explain. Line plots display individual data. All right, well, let's take a look again at a line plot so we can construct an argument. Okay, so here we have, let's say, pets in a home. 0, 1, 2, 3, 4. And, we surveyed some people, and this is the data that we got. All right. Each X equals an individual piece of data. I can absolutely see that 2 people had 4 dogs or pets. 1, 2, 3, 4 people had 1 pet. 3 people had no pets. So it is true. Each piece of data is represented as a dot or an X on the line plot. Question 11. Reason inductively. The line plot shows the number of student visitors to the National Wildlife Refuge each day for 2 weeks. If the 4 X's at 56 were not included in the data set, which measure of center would be most affected? Justify your response. So what they're asking us to do is to take a look at the data and compare the data landmarks with and without these 4 data points. So we're going to take a look at the median, mean, and mode and range with the data, and the median, mean, mode, and range without the data. I've listed the data here from least to greatest, and we're going to find the median. The median with the data is 62. Now we're going to take a look at the data and find the mean without our data points. So now I'm going to pretend that these numbers don't exist. The median without the data equals 63.5. Now it's time for us to calculate the mean. We're going to add up all of the values and get a sum. When you do this, you should get 859. Now you need to count how many data points we have. There are 14. When you type 859 divided by 14 in your calculator, you should get an answer that looks like this: 61.3571, and it keeps going. When we have long decimals like this, now that you're in 6th grade, I would round them to the hundredths place. So in this case, it's 61 35/100ths. Now we're going to take a look at the mean without the 456s. If you add 58, 60, 62, 62, 63, 64, 65, 65, 68, and 68, you should get 635. Now we don't have 14 pieces of data anymore, we only have 10. We don't need a calculator for this because we know when we divide by powers of 10, we simply move the decimal point 1 space to the left, which is 63.5. So our mean is 63.5. Next, let's take a look at the mode. We're going to go back up to the chart. The graph. With our data, the mode is clearly 56. If I take that out of the equation and look, I actually have 3 modes. So if the 56s weren't there, I would have 62, 65, and 68 as modes. All right, now let's take a look at the range. For range with the data, our maximum is 68. I'm going to write this up here. Range with the data would be 68 minus 56, which equals 12. Our range without the 56s would change our minimum. Our maximum is still 68, but our new minimum would be 58, which is a difference of 10. So as we're looking at our new values, the median only changed by 1.5. Difference is 1.5, and we're just going to say it's the absolute value because it doesn't really matter if it went up or it went down. We're just saying in general it changed by 1.5. Okay, now let's take a look at the mean. The mean did change. Sorry, I lost my pen again. Okay, so the difference here, the mean went from 61 and 35/100ths to 63 and 5/10ths. That's a change of 2.15. Okay. Now for the mode, we went from 1 mode to 3 modes. 1 to 3 modes. And the range decreased by 2, so the change was 2. All right? So in summary, we could say, and it does look like I have some overlap here, but mode, sample answer. With the 4 values, the mean is 61.36, the median is 62, and the mode is 56. Without the 4 values, the mean is 63.5, the median is 63.5, and the modes are 62, 65, and 68. Not including the 4 values changes the mode more drastically. So for this answer, they were looking for the mode being changed the most when we take out the 56s. Well done, everyone, and that brings us to the conclusion of our video, and I wish you a fantastic day. Thank you. This was Mrs. Smith.